It's not always possible for teams to work together in the same room to program and test their robot. Instead, the robot may be at the home of one of the team members or the coach or some other location. The teams can meet using internet video conferencing services to discuss the robot game, but how can they work together to design, build, program, and test their robot? I'll assume you already have some ideas about using video calls to collaborate on the design and building of the robot and focus on the programming and testing steps. The software for FTC blocks and Onbot Java lives on the robot controller phone or the Rev Robotics Control Hub. How can team members at locations away from the robot work together on programming the robot? This video focuses on a sharing mechanism that works in real time. Because the team probably only has one robot kit, the robot being programmed will be at one team member's location or perhaps at the coach's location. The team members can work together from their individual locations, taking turns on who is doing the programming while the others ask questions and make suggestions. To make this real-time sharing work, we take advantage of a Google feature called Remote Desktop. This feature allows one computer to see and control another. Let's consider a simple situation where a team member has built a robot and dropped it off at the coach's location, and another team member wants to program the robot. Let's say the team member who wants to do the programming is named Jane, and we'll call the coach, Coach. The first thing Coach needs to do is set up a computer so that it can use the internet to communicate with Jane and at the same time use a Wi-Fi connection to communicate with the robot. To accomplish this, an Ethernet cable can be connected between Coach's Wi-Fi router and computer. The second thing Coach needs to do is install Remote Desktop. Coach goes to a page called remotedesktop.google.com/support. Coach clicks on the download icon to install the Remote Desktop software. This installation step only needs to be done once at each computer where the program will be hosted. The third step is to pair the driver station and the robot controller. Connect the computer to the robot controller using Wi-Fi and use a browser to log into the robot controller. The team can use just about any video conferencing solution they want, but for this demonstration, we'll use Zoom. Let's assume that Coach previously scheduled a Zoom session and emailed the link to Jane. Coach starts the Zoom session. Jane uses her link to join the session. Now Coach opens Zoom's chat window, types the Remote Desktop link, adds a /, the word session, and another /. Then Coach goes back to the Remote Desktop page. Coach then clicks on Generate Code. A code is displayed on the screen. Coach copies the code from the Remote Desktop page and pastes it at the end of the web address. Jane then opens chat on her computer and clicks on the link. This causes a web browser window to open and the code provided by Coach to be placed on that page. Jane then clicks on Connect to obtain remote control of Coach's computer. Coach clicks on Share to allow remote control by Jane. Note that Remote Desktop allows Jane to see Coach's screen even though Coach hasn't asked Zoom to share it. The sharing comes along with the remote control provided by Remote Desktop. Jane now chooses Blocks or Onbot Java on Coach's computer. Let's say she chooses Blocks. Jane clicks to create a new op mode. It's asking for the name of the op mode. She can use her keyboard and Coach's computer acts as if Coach is doing the typing. Jane inserts blocks to create a simple autonomous op mode that drives the robot forward for 1 second. When Jane has finished the draft op mode, she saves it. Jane can then ask Coach to point his or her webcam at the robot and use the driver station phone to start the autonomous op mode. Coach may need to turn off Zoom's webcam mirroring feature so the robot moves as expected on Jane's computer. The robot probably won't do exactly what Jane wants the first time, so she can make changes and continue the process with Coach repositioning the robot. When they're done, Coach clicks on Stop Sharing to discontinue the remote control of his or her computer. To keep this video relatively simple, I've shown only 2 people collaborating in arbitrarily chosen Zoom to demonstrate video conferencing. Your team can use other video conferencing software like Google Meets or GoToMeeting. Remote desktop can also be used for meetings of several members with or without coaches. For instance, one team member could play the role that Coach played in my demonstration, assuming that the team member has a robot at their location. Several team members can be on the video call, taking turns using the remote desktop link to program the robot. In that case, each of them would need a new remote control code when it's their turn to take control. Most video conferencing platforms have a screen share feature, and some, like Zoom and GoToMeeting, have a remote control feature. Unfortunately, Zoom and GoToMeeting don't support remote control when you use a Chromebook. Fortunately, when Google Remote Desktop is used in conjunction with these platforms, the team gets both features in all the combinations shown. So, this video has focused on using Remote Desktop because it provides both features for all these combinations. The main requirement is that computers must have a recent version of Firefox, Edge, or Chrome for Windows, or Safari, or any of the other browsers for Macs. We've seen how Google Remote Desktop can be used to allow teams of students to collaborate on programming the robot and testing their programs.